So this is where the task queue or the callback queue kicks in. So basically, any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs it, right? So here we can see that now the stack is clear. There's a callback on the task queue, so the event loop runs. It says, oh, I get to do something here. Pushes the callback back onto the stack. Now remember, the stack is like JavaScript land, right? This is back inside V8. So the callback appears on the stack and gets run, console.log there, and we're done. Does that make sense? Everyone with me? Awesome. OK. So now we can see how this works with probably one of the first encounters you would have had with async stuff, which is when, for some weird reason, someone says, oh, you have to call setTimeout0. Like, OK, you want me to run the function in 0 time. Why would I wrap it in a setTimeout? Like, the first time you come across this, if you're anything like me, you're like, OK, well, I sort of see that it's doing something, but I don't really know why. And the reason is, generally, if you're trying to defer something until the stack is clear, right? So we know, looking at this, if you've written JavaScript, that we're just going to see the same result. We're going to see hi, we're going to see JS-conf.eu, and then there is going to somehow appear at the end. So running it, we can see how that happens. Console.log hi, set timeout 0. Now that's going to complete immediately and push the callback onto the queue. But remember what I said about the event loop. It has to wait until the stack is clear before it can push the callback onto the stack. So your stack is going to continue to run, right? Your main file is going to continue to run, console.log JS-conf.eu, and clear. Now that we're clear, the event loop can kick in, run your callback. So that's like an example of set timeout 0 is like deferring that execution of code for whatever reason to the end of the stack, or until the stack is clear. OK. So all these web APIs work the same way, right? If we have AJAX requests, we make an AJAX request to a URL with a callback. It just works the same way. Oops, sorry. Console.log hi, make an AJAX request. The code for running that AJAX request does not live in the JavaScript runtime. It lives in the browser as a web API. So we spin up a XHR web API with a callback and the URL. Your code can continue to run until that XHR request completes, or doesn't complete. It may never complete, but that's OK. Your stack can continue to run. Assuming it does complete, callback gets pushed onto the queue, picked up by the event loop, and it's run. Right? That's all that happens when an async call happens. OK, so let's do a crazy complicated example. So I hope this is going to work. If you hadn't kind of realized, like, oh, this is all in Keynote, there's like, I don't know how, like 500 animation steps in this whole deck. So hopefully that, oh. Huh. Oh. So, interesting. We were given a link. Is this big enough? Can people see? OK, so basically, I wrote this talk for Skeleton.js earlier in the year, and I did it there. And then after the talk, I broke half of the slides and could not be bothered to redo all the slides, because it was a total pain in the ass in Keynote to do it. So instead, I took the much easier route of writing a tool which can visualize the JavaScript runtime at runtime. And it's called Loop. So let's just run this example, and which was kind of the example we had on the previous slide. I haven't shimmed XHR yet. It's doable. I just haven't done it. So as you can see, the code, we're going to log something. This is a simple shim around like document.add event listener. Set timeout, and we're going to do a console.log. So I'm just going to run it and see what happens. So add a DOM API, add a timeout. Timeout's going to count down. Code's going to continue to run. Pushes the callback onto the queue, which runs the console.log, and we're done. If I click on here, then it's going to trigger the web API, queue the callback for the click, and run it. If I click 100 times, we can see what happens, right? I've clicked. The click doesn't get processed immediately. The click gets pushed onto the queue, and as the queue gets processed, eventually my click is going to get dealt with, right? So I have a few more examples I want to run through here, except I don't know how to see tabs. So let's just see if I can find it. There we go. OK. So I'm just going to run through a few examples just to kind of talk about a few things that you might have run into and not kind of thought about with async APIs. So in this example, we call setTimeout 4 times with a 1-second delay and run console.log hi. So if we run it, we can see that we run a few timeouts, but the timeout callbacks get queued. Right? So that fourth callback, we asked for a 1-second delay, and it's still waiting. The callback hasn't run. Right? So this kind of illustrates what setTimeout's actually doing. setTimeout is not a guaranteed time to execution. It's a minimum time to execution. Just like setTimeout 0 doesn't run the code immediately, it runs the code next-ish sometime. Right? So in this example,